Hello, everyone. It's me, Courtney, again. And today we're going to learn about tides. And to start off, I would like to kind of explain my fascination behind tides and why I really think they're super cool. I got to go to the beach a lot, and I loved to swim and play in the waves and boogie board and hang out with my friends. And I also really liked to build sandcastles. I was obsessed. I remember this one time I wanted to build an indestructible sandcastle. Crazy, I know, right? But I was really determined, and I probably worked on it for about an hour until I was pretty satisfied with it and wanted a picture. And when I went to go get a camera and it came back, I realized the ocean had gotten way too close. Within minutes, my castle was gone. It was sad, and I was super bummed because I had planned it to be so far from the waves that they shouldn't be able to come up and reach it, right? But I was wrong, and the water was able to move up the beach. And I wondered, well, why doesn't the water like keep going? Like, why doesn't it go all the way up over the beach and onto the road? And why is it low sometimes? Like, what is going on? So I had this really crazy fascination. Like, what is going on? What destroyed my sandcastle? Um, and I now know that there's actually a tidal cycle that happens every day. There are two high tides and two low tides. Um, why do you think this is? The answer is a little more complex than what meets the eye. It involves the moon, the sun, the power of gravity, and a lot of magic. Let's check it out. So here I have a model of the Earth. It's a beach ball, and we all know that it spins around. In fact, every 24 hours it makes one rotation. And that's why it looks like the sun is moving around when it's actually just our Earth spinning on its axis. I also have this model of the moon. It's a lacrosse ball. And it also spins around, but one day on the moon is actually the equivalent of 29 days on the Earth. So it takes a lot longer on the moon for it to spin around. But also, we all know the moon is orbiting the Earth, right? And this motion here is called a revolution. So the moon is revolving around the Earth while spinning, but it spins pretty slowly. And actually, the revolution and rotation of the moon is the same, 29 days. So essentially, what that means is the face, let's say this is the face facing the Earth, is always going to be facing the same way. So we never see the backside, the moon, right? It's always facing the same way. That's a pretty cool fact. So we have these two objects at play here, and they're actually affecting each other through an effect called gravity. And it's actually the driving factor for tidal changes. And the strength of gravity is determined to how close or how far things are. So if two objects are very close together, their gravitational pull is much stronger. The force there, much stronger than if the same two objects are farther apart. So distance plays a very key important role here. So remember, farther, weaker, closer, stronger. We got this. So this in mind, we understand that the moon's gravity is going to act more strongly on the ocean that's closest to it, right? It's closer, stronger. So the moon is pulling the ocean closest to it and creating a high tide. The Earth itself is actually also being pulled here. The Earth is actually kind of moving also towards the moon. And the far side, the water on the other side of the Earth, is not being pulled as strongly. It's actually weaker. So it's kind of being left behind as the whole Earth itself is moving towards the moon. So it creates another high tide on that side. Pretty crazy stuff. And this happens again because objects are closer together have stronger gravity than objects that are farther apart. In this case, the ocean. So that's why there's two high tides, and the two low tides are in between those two high tides. So when kind of like at the 90-degree angle of where the moon is acting upon the strongest point. But this isn't quite the whole story. I encourage you to go ahead and check out part 2 for a deeper dive into how tides work. See you there.